Hello all, welcome to the next video lecture in which we are going to study about the hash functions. In the previous lectures, we've already studied regarding what are the types of authentications, what are the different requirements of authentications. Then we saw what are the different authentication functions, in which we saw that there are three authentication functions, and out of that, hash functions is one of the authentication function. So let's begin with the hash function. What hash function basically is? Hash function condenses arbitrary message to fixed size. That means if we implement the hash functionality on any of the message, then it converts a complete plain text message into a fixed sized message. Usually assumes that hash function is a public function. That means the hash functionality is implemented using the public key of the senders. Hash used to detect the change of messages. Then, for the hash functionality, we do require a cryptographic hash function, which then also can be useful for implementing the digital signature. Computationally infeasible to find data mapping to specific hash, which we can consider as a one-way property. Also, it is computationally infeasible to find two data to same hash, which can be considered as the collision-free property. So this is basically a normal cryptographic hash function wherein we can see that the message or data block of M, that is a block which is here considered as a plain text block, as M having a variable of length L, which is then undergoing the hash functionality, and then the output what we get is the hash value of the plain text message block, and that will be then a fixed length. So what are the different hash functions and its uses? The first one is the message integrity check, that the hash functionality checks the integrity of the message. Sender which has sent the message, so send hash of the message, which can also be here considered as the digest. That means whatever the hash functionality we are implementing, that should be properly transferred over the network, and then it should be properly received at the receiver's end so that the receiver will then be comparing it. Message integrity check, always encrypted, the message optional. Then there is the message authentication code, which send the keyed hash of the messages, and MAC also messages encrypted optionally. That means when the keyed hash functionality has been implemented using the MAC on the plain text, then it is, if the requirement, then the encryption will be taken place. If not, then it is the option for encryption of the message over the keyed hash function of the message. Digital signature, that is used for checking of the requirement of the non-repudiation. Encrypt hash value with private key. That means whatever the hash function we have implemented on the message will then be encrypted using sender's private key. We'll be seeing the figures in detail. And then that particular keyed hash encryption then will be compared at the receiver's end by the verification key. And then for the verification, the receiver uses public key of the sender. Now these are the hash functions and how the message authentication takes place. Here we are seeing that symmetric keyed and unkeyed hash functionalities. The first figure will give you how the message encryption takes place, and the second figure will tell you about the unencrypted message. The first figure, if we can see in the first figure, we can see that a plain text block M is undergoing the hash functionality, after the output what we get, then that particular output will be, then that particular output plus the original message is XORed, and whatever we get here will be then undergoing the encryption process, and for that encryption process we will be then utilizing a key here. Then we can say that whatever the output is we are achieving is the keyed, that is the encryption has already taken place on the hashed value of the plain text message, and then when it is being received at the destination, that means when it is being received at the receiver's end, decryption will take place with the help of the key, and then whatever the hash functionality has been implemented will be then compared, and for that comparison destination B will then be implementing some of the method for the comparison. That means whatever the message the destination has received is same or not as that of the message which has been sent by the source A. So here, with the help of the encryption and the hash functionality implemented on the plain text block M, we then can maintain the integrity of the data. Figure B can be seen that wherein the message is only hashed and encryption has not been taken place. We can see that the message has undergone the hash process, hash functionality has been implemented, and whatever the output we have got after the hash implementation, then that particular thing has been encrypted. The original message hasn't undergone the encryption process as it has been taken place in the figure number A. So here the message has, the hash functionality has been implemented with the hash functionality, and then it is being encrypted, and then it is XORed with a plain text message received at the receiver's end, and then it will be compared at the receiver's end. So this particular figure depicts about the message which is unencrypted after the hash functionality. Now this is the hash function which and the message authentication which are using the symmetric keyed hash. The figure number C tells you that the message plain text block is there, which is then undergoing the hash functionality. For that it has undergone the hash functionality, and then whatever the output we get, that output is then XORed with the plain text message, and then that hash function has been appended with the plain text block M, and it is being then received at the receiver's end. So S here denotes the symmetric key. In the figure number D, we can see that the message undergoing hash functionality, then it is encrypted. For encryption, again it is using the keyed hash, and then when we get the output, we get the keyed hash functionality which is being implemented to get the encryption of the plain text block, which then received at the receiver's end. When it is being received at the receiver's end, we can see that it is first decrypted. For decryption, it will be then using the symmetric key, and when it is being received, when the output is received after the decryption process, the only hash function has been appended with the message. That means the only hash function has been appended with the plain text block M, and then this hash function will then be compared at the receiver's end to check the integrity of the message. So here we can see that what the difference it is being having when it is unencrypted and when it is encrypted. So when we can easily here differentiate that the processes which are encrypting the messages after the hash functionality will be then giving you the higher intensity of the security to the message which is being then transferred over the network for the destination user. Here we can see that public keys, cryptographic can be technique is can used for the hash functionality and for the encryption process. Figure A depicts that the message undergoing hash functionality, after that it is undergoing encryption process, and for this encryption key which is being used is the private key of the sender, that is PRA. Then it is appended with the plain text block M. We can see the output here, which is the encryption part of the hashed plain text message, and the encryption has taken place with the private key of the sender. Then at the receiver's end, that means at the destination end, the decryption will take place and comparison will take place, and decryption will then take place with the public key of the sender, that is PUA, which is known to the destination, and then it is being compared. Similarly, the second figure tells you how after the hash functionality, the encryption step has also been applied on the hashed plain text message. For that, it has again used the private key of the sender, and then at the receiver's end, it is then decrypting the encrypted hashed message with the public key of the sender, and then the comparison has taken place. So here we can say that when the encryption is being taken place and when the decryption is taking place, these both the steps are utilizing the symmetric keys only for encryption and decryption. But when the comparison of the hashed messages have to be done at the receiver's end, the receiver will then be using the public key of the sender, and sender is using the private key of its own, which then again helps in creating the digital signature part of the hashed functions. We can even say that the digital signature has again been implemented for maintaining the integrity of the data, and when we are saying that we are implementing the hash functions, we are implementing the encryption process, that means with these two processes we are also achieving the concept of the confidentiality. So with the hash functions, we can have the confidentiality, and we can even implement the digital signatures to improve the security of the data, security of the plain text block, which is then received at the receiver's end. Also, it ensures the integrity of the data to the receiver. These are some other hash function uses. It uses the pseudorandom function, which generates the session keys, and the nonces. Nonces are nothing but the newly generated numbers for every step, we can say. They produce key from passwords. They derive keys from the master key cooperatively. Pseudorandom number generators also the hash functions also uses the random number generators. For that, the Varnam cipher, OTP, S key, proof of what you have via the messages, these type of the messages, then they use, or these type of the steps, then they use for the generation of the pseudo random number generators, which the hash functions uses for their implementation part. Some more hash functions uses to create one-way password file, and for the intrusion detection and the virus detection. For one-way password file, store hash of the password, not actual password. Examples like Windows, Unix, Windows NT, etc. Rainbow tables it uses for intrusion detection and the virus detection. It keeps in check hash of files on the systems, and for that the tripwire can be considered as one of the examples. Two simple insecure hash functions are there, which considers bit by bit exclusive OR of every block, wherein we can have a longitudinal redundancy check, and reasonably effective as the data integrity check is also there. The other function which is insecure, we can say, is 1 bit circular shift on the hash value. For this, each successive n bit block is being circularly shifted. Rotate current hash value to left by 1 bit and XOR bit. This is good for data integrity but useless for the security. So these are some functions which are considered as the insecure hash functions. These are some of the requirements of the hash functions, wherein that it has the requirement of variable input size, fixed input size. It has the requirement of efficiency, then primage resident, that is a one-way property which we have seen. Second primage resident, that is the weak collision resistance, for which a given block, if suppose has X, it is computationally infeasible to find Y of it, that is hash. It is computationally infeasible to implement the hash functionalities on the Y, hash functionalities on the X. It is computationally infeasible to find any pair, which we have seen in the collision resistant. Pseudo-randomness out of H meets standards tests for the pseudo-randomness. So these are some of the basic requirements which the hash functions require for their proper implementations to maintain the security and to provide the proper encryption processes to the data, to the message. Thank you. I just hope you might have got the concept, the basic concept of how the hash functions are being used. We'll be seeing how the security of the hash function is achieved in the next lecture. Thank you.